how to use Robot Studio. Now normally I'd be giving you guys this little demo in class, but obviously everything has now been transferred to online. So here is kind of a little brief walkthrough on how to use Robot Studio. How to use Robot Studio for ELE 140. Now, the first thing I want to talk about is file. Now, you can start from a new solution with an empty station. However, normally I would do a solution with station and virtual controller. And the robots that we have in class are IRB 120s. So you'd want to use the robot model IRB 120 3 kilogram here. Now, at some point, it is going to ask you if you want to, which model type do you specifically want to use. There is an IRB 120 and an IRB 120T. I don't know what the difference is, but we always go with the standard old 120. Now, another option is if your teacher gives you the package or a group of files already for your robot, your simulation, whatever it is, you can also import a whole setup right off the bat, and that's what we're going to do today. So if we go to the share screen, we can unpack and work. So we're going to select that and just walk through the menu here. So first we got to select our file, which I have mine in my classes, in my public documents. There we go, ABB Project 1. We're going to open that up. It's going to open that or export it, unzip it, whatever you want to call it, in the Documents Robot Studio Solutions folder, which is fine for our purposes here. I'm going to add C1 to that just for good measure. I think this project already exists in that folder, so I'm going to add that for my purposes. And we're just going to go ahead and hit next. And we're going to say automatically restore backup. We don't need to worry about creating a configuration folder. And then we can go ahead and hit the finish button. Here you can see that we're unpacking the station, we're creating a virtual controller, restoring the backups, yada yada yada. It's just going to take it a minute. Depending on how fast or good of a computer you have, this may or may not take a little bit of time. So just go ahead and be patient. Now after a little bit of time, you should get to this point where it says unpack and work finished, and then there will be a close button, and in the background you should see whatever was in that package. So we can go ahead and hit the close button. Now, at the bottom here, all right, we have our output, which shows all of our messages and whatnot. Now, these are all from, what time is it? Nope, right this instant, which is awesome. All right, so this actually grabs how I had things set up before, I started creating this video. So, which is really nice. It'll hopefully keep some problems from happening, but that's okay. We'll come back to some of those problems. So if we look right now, you can see I've got a robot here. If you click and drag, nothing happens. If you push the scroll wheel in, nothing happens. We can scroll in and out. We right click, not much happens. We get a menu. All right. If you want to navigate around, you can kind of just put your mouse in center somewhere, and when you zoom, it actually centers on the mouse wherever your mouse is, which is kind of handy. Alright, now if you hold the control button and left click and drag, that will allow you to move around the environment. Alright, and if you hold control and shift and click and drag, that will orbit the environment. Alright, so that will allow you to change your perspective, look around things, those types of stuff. So it's kind of a combination of left control to drag and then hold shift to spin, and then you can kind of just keep doing that over and over again and do some kind of funky things. If you have some other fancy tools for CAD work and whatnot, like a little 3D mouse, which I do have, you can actually use that, which makes me very happy that they actually included that option in the software, which is sweet. But most of you guys are probably not going to have one of these, and I don't know if I'd actually suggest buying one at this point in time. But anyway, I digress. So what we have here is I have an ABB IRB 120. All right, I do have a smart gripper attached to it. All right, and if we zoom in, you'll actually see that we have two suction cups, one top, one bottom, and we actually also have a smart gripper set. So we, in theory, can open and close these and pick objects up and things like that. Hopefully we'll get to there. All right. However, I just kind of want to go over a few things in this video. So first, we got our robot. Now, This is a full simulation, so we have a simulated teach pendant we can use. We can write programs. We can do all sorts of wonderful things. On the ground here, I have 2 pen end attachers, basically. All right, that I just put in so that way there were some targets on the ground and things like that for you to try to get your robot to and whatnot. So I figured we need something to play with, so this is what I am using for you guys. All right. Yes, we are a bit close to the robot, but I have my purposes for that, so just deal with that when those problems occur. All right. Now, first thing that you're going to want to do is we're going to go to the controller tab. Sorry, the simulation tab, not the controller tab. Where is it? Nope, it's the controller tab. I'm wrong. We're going to go to the controller tab. All right. And we want to, under virtual controller, we want to open up the operating mode window. Now, by default, the robot is in auto mode. All right, and notice here it does say IRB 123 kilogram, 0.58 meter station. All right, if you had multiple robots in here, which we can do multiple robots in one simulation, which is, again, pretty neat. All right, both of them would be listed, or all of them you would have would be listed, and you have to select which one is correct. If it doesn't have anything listed here yet, that's because if we look in the bottom right-hand corner, right now mine says controller status 1/1 and it's green. All right, if there's nothing listed there, that's because your controller hasn't booted yet. So just something that you do need to be aware of. So something to keep your eye on. So that should be green down there. If it's not green down there, we've got some other problems. You should be contacting me probably. Now, if you want to be able to manually control the robot, first we have to put it into manual mode. All right, which down here at the bottom, you know, our output does change. It says safety guard stop state just popped up, and now it says manual mode selected, which is all well and good. We also need to enable the device. So you can go ahead and click that enable device button. You'll see it goes motors off state, and then it will say motors on state. All right. So in theory now, if we had our flex control pendant or open, we could actually control this thing. To open the flex pendant, that is under the controller tabs, and there is a button for flex pendant. If you have a lower resolution monitor than I do, which may or may not be the case, this is a 1080p monitor. You know, it might just be the symbol. It might not be the whole, you know, let's go ahead. So there, it's that little itty bitty button right there. So just something that you need to be aware of, that may or may not, you know, be the case. So it is kind of annoying that you need to have a larger screen, but the bigger the screen, the kind of better off we are at this point. Now, our flex pendant opens up. You can move it around. You can also kind of minimize it and give you just the control aspect of it, which is nice to have for simulation purposes, since you know, you might not have as much screen real estate as I have. I know when I was on a laptop doing this at school, I think when we do this at school, the flex pendant takes up most of the screen, which really kind of sucks. All right. I have 2 monitors at home, and I find it really useful to have the flex pendant on one screen and the simulation on the other, so I don't have to like be like, oh, where can I put this so I can still see the whole robot and everything, or I don't have to like very carefully position the robot in like, you know, a really small corner so that way I can still see the flex pendant or those types of things. But it's gonna be a fun one, but you guys can make it work. Now on our flex pendant, we have a lot of information being shown. Up in the top left, we have a little menu. It's kind of like the start button on Windows. All right. Notice we have a hot edit option we're not going to use. We have inputs and outputs, which we should get to later this semester. We have jogging. All right. We have the production window, which is where, not where we are currently. I thought we were in the production window, which just looks like that. It says program pointer not loaded. So if we hit PP to main, there's no, oh, there we go. We do have some code. All right. Now, one thing to note here. All right. This is, remember, this is simulating an actual touchscreen. So like I can't just scroll. There, you know, there's a lot of limitations here. So sometimes you'll see arrow buttons on the screen. Let me just bring up the program editor. Not that we're going here, but like I can't just scroll. I'm on line 23. You think I'd just be able to like, you know, move my roll up and down? No, you have to use the little arrow buttons here to move around, which is kind of annoying, but that is just the way the game works sometimes. So just remember, think of this as a touch screen that you're using like your finger to poke, so you can't just use a scroll wheel. The normal keyboard, I believe, does still work in certain instances, but there's also an on-screen keyboard that you can use. Anyway, we got program data, which is where all of your different variables will be. So notice we have a num category right now with registers 1 through 0. We could create a new one here. We just call it Greg's. All right. Type is global, local, or task. We have what task we're in, what module, if there's a routine associated with it, dimension, all those wonderful things. You can select an initial value. Right now it's 0. I'm going to make it 52. And we can just go ahead and hit OK and hit OK. And look, now, oh, my name's wrong, but OK. I have a value of 52 as a variable. We have some backup and restore information, some calibration stuff. All sorts of wonderful things. However, right now what I'm most worried about is jogging. So, oh, I didn't mean to click. All right, so if we go to the jogging screen, all right, mechanical unit tells us our robot that we selected. If you have multiple robots off one controller, which there is a way to do, use the same flex pendant to control them all. So that's why it tells us what mechanical. Motion mode, all right, we have 4 options. We have axis 1 to 3, axis 4 to 6, linear, and reorient. Now, what this is doing is it's adjusting the purpose of our joystick over here on the right. We notice right now we've got an up, a down, a left, a right, and a twist. So we actually have 3 axes of motion on our joystick compared to the traditional 2 that you might be thinking of. So you have an X, a Y, and then you also have a Z, or a rotation axis, all right, which is why this is axis 1 to 3 and 4 to 6, all right. We have a linear mode and we have a reorient mode. So in axis 1 to 3, if we drag this over just enough, actually, let me do what I said I hate having to do, which is reposition the robot, but it makes my life the easiest. All right, and if I push up, now notice right here it says joystick direction. So if I push right, you'll see axis 1 will increase. All right, so we're up to 5. If I push left, it will decrease. So that's what the arrow is. It's which direction on the joystick is which position and which way is positive. So if I want to move 2 down, I actually push 2 up. A little backwards, but it kind of makes sense when you think about what you're moving this axis up. All right, remember we start counting at the base. So this would be axis 1. That one right there, that pivot is 2. This pivot between these 2 is 3. Pivot between those is 4. Pivot between that is 5. And those 2 is 6. So always start at the base and count your way out. So that is why we have we have axis 1 to 3. If I should change 4 to 6. All right, and I would do 6. You would see the end effector is rotating right now. All right, so that is what that is. If we go ahead into linear mode, this will change this into, if you notice, X, Y, Z. Now this is X, Y, Z, assuming you are facing the robot like this. So you see the plugs coming off the back of the robot, this box, that is the back of the robot. All right, and by default it assumes, will give us a little bit of an angle here. All right, it assumes that if I push left now, the robot will move to my left. If I push right, it'll move to my right. We go back and we go forward. Okay, awesome. Too close to singularity. All right, robot is too close to singularity. That means, let me just hit acknowledge. All right, it's at a point where it doesn't know what it should do next to keep moving in that aspect. All right, because if we look at it, all right, normally something is too straight, or it's something really funky. All right. So if we get too close to singularity, you can just move in the opposite direction that you were. All right, and oh, there we go again. So we got some funkiness going on here with this straight axis. Now, oftentimes I like to, when I get those problems, I move into a joint mode, and 1, 2, 3, 4, I want to move 5. All right, I'll move 5 down, and I can go ahead, and now if I go back to my linear, that probably will solve most of the problems that I was having. All right, when the robot's in like a perfectly straight line, it is very unhappy about doing that. So that's kind of what that singularity mode is. All right, so that's linear, and the last one is reorient. Actually, let's go back. Now this is linear. The directions, those X, Y, Z, are based on the coordinate system. Right now we're set to base, which would be the square down here at the bottom. Base and world are probably basically the same. Tool actually worries about which one of these 3. If you notice how these are at angles right now, let's rotate and move it. All right, so tool actually worries about these. Now the blue line, I believe, is the Z axis. Yep, blue is Z, red is X, green is Y. So if I did it based off of which one is that? Oh, that doesn't tell me, it just tells me, there we go. That is pneumatic, it doesn't tell me which one. So, if I were to change that to tool, and then change tool, oh, no, wrong one. Change tool 0 to vacuum 1, you'll notice that Z now moves in a whole different direction. So, changing your coordinate system becomes very important. Now we won't be dealing with this till later in the semester. Keeping this as base will be keep most of your problems from happening. The last option is reorient, and again that tool does affect it. So no coordinate system automatically goes to tool for the reorient. We're worried about, I think it's this point in space. Let's find out. Nope, it's this bottom one. I chose the wrong vacuum. So reorient will keep this, where these three, because this is the tool we have selected, it will keep those three in exactly the same point in space. Now, to prove my point, let's just go ahead and throw this to linear for a second. We're at 359, roughly 45, 464. Let me go ahead and write those down because I will forget them. 359, 45, 464. All right, and we're decimals of a millimeter, but that doesn't really matter. All right, so in reorient, let me just get rid of this so you can still see. If I click these buttons, let's go away. So I've just reoriented this in all three axes. And if I go back to my linear mode, you'll notice 359, 45, 464 with all those decimals. All of those places stayed the same. What changed were all these Q values. All right. We talked a little bit about this earlier in the semester, how with a 3-axis robot, it's very easy. It always is going to go pick up that object from the exact same way. Well, once we have the 6-axis, we now can pick it up with our hand on the right or the left or above it, below it, or whatever angle in between, as long as we can reach it. So at that point, those angles become very, very important. And you can see how crazy funky we're at right now. All right. So those Q's become very important. I believe it was something like when you square all of these and add them up, it gets the value equals 1, if I remember correctly. Let's quick find this out. So 0.35927 times 2 plus 0.40674. Oh, not times 2. My bad. Clear it. Let's just delete it all. Alright, what is it? 0.35927 squared plus 0.40674 squared plus 0.83990 squared plus 0.00731 squared equals 0.999997866. So, we're very close, and that's probably because we're missing some decimal points here. So, that's what's going on. If you were to round this, that would be 1. So, I don't know how they calculate the Q's. It is some crazy reverse kinematics stuff going on there, but anyway, that's what's going on. So that's what the motion mode is, and you can see how that can be very useful depending on what you're trying to do. Sometimes moving joints is the better option, or at least the quicker option. Sometimes moving linearly is the quick option. Okay, so tool we talked about, work object we're not going to talk about, joystick lock. All right, if it's not as big of an issue with the simulation because we have very specific arrows. But when you are dealing with, in the real world, the joystick, you might push it to the side ever so slightly, and that might screw up your Z or your X or whatever axis. So you can actually come through and lock all 3 or just 1 or 2 or something like that. Not really an issue on our purpose, but it is an issue in the real world. Increment, also a very important one. None, small, medium, large, user. All right. I like to jump between medium and none. Those are probably the 2 that I use the most. All right, so right now we are at none. We are in jog mode. So if you notice, if I jog down, we move pretty quick. All right. If I drop this to medium and I now try to jog up, notice how much slower that is moving. All right. And again, in the simulation environment, not really in the world, because if you crash into something, it's not a big deal. In the real world, when you're moving around and you crash into something, the robot locks up. Sometimes you can get it out by using the jog and the small, and you can just start slowly jogging it up. Now, right now, if I move this, you'll notice we're moving like 0.3 millimeters at a time, at an increment or something like that up here. If we go down to small and I do that, it's moving by like 0.03 or something like that. So that increment can be very important. Now, some of these things we can configure without having the jog screen open, which is where this becomes important. So this center gray button right here, just to the left of the joystick, if you notice, that has the reorient picture and the linear picture on it. And if you look at the bottom right-hand corner in Rob_1, if I click that button, it will jump back and forth between those two options. This one says 1/2, so that's saying joysticks position 1 to 2, 3, and 4, 5, and 6. So you can change nicely that way. We also have this gray button with the 3 dots right below it. That is our speed. So right now it jumps between small and none. So the last two that you I think it jumps between none and the last one you use. So I like to jump between small and medium. So there you can just press that button and just jump back and forth. So even if you're on like the program editor screen, that is all still there. You can be like, okay, I need to be in linear, and I need to move, and then I need to move slower now. So you can get a lot of information just by having that little screen there and those few buttons. Now, getting things aligned is a little bit harder now in the simulation world. You do kind of have to keep track of which way, what's facing, and all those other fun things. So let's say I'm going to try to line this suction cup up, the center point of that with the center point of this pen. All right, you're going to constantly kind of be jumping back and forth between things. Let's go ahead back to fast mode, and now we can go down. And I think we're going to go back a little bit. And this is why it's kind of annoying, because you kind of have to always constantly be reorienting. Now, sometimes what I like to do is say, get yourself straight on, move until they line up. I'm going to say they line up, and get yourself perfectly from the side, move until they line up that way. And in theory, at this point, we can also move down until they line up. And now if I zoom in, you can see how, oh, that's right, I'm kind of looking at this from the wrong way. Here we go. You can see how close I was able to get just by, basically 2 views. One front on to get the X or Y's lined up and the Z lined up. So, this, you can also see how, I would say, actually, I'm just going to call that I need to move down just a little bit. And I'd say that's about as close as I could physically get that in the real world. Probably closer than I could get that in the real world. Alright. Now when I tell you guys to line things up for this class, that is plenty close. Alright. I don't need it, this to be exactly where that point is. Alright. Now, to do some programming. Alright. If you come into Program Editor, it may not have a program in here yet. It may say you need to create a program, which would be fine. Alright. So, our little program we're going to write today, or you're going to write at some point before it's due, is going to basically just to move the robot, just like we kind of have done, from one point to another. All right. So right now, I want to add an instruction, and here are our most commons. So we have a compact if, a for if, move ABSJ, move C, move L, move J, process call, reset, return, and set. Most common, and there is another common screen here. But we've talked about move J versus move L. Now, just a quick reminder, move L is a move linear or straight line. Move J is going to move in the most efficient way, we'll call it, for our joints to move into. All right. So in this case, I'm going to go ahead and hit the move J button. And it says, do you want to insert above or below the currently selected one? If I hit cancel, you'll see I am selected on add your code here. All right. You can normally zoom this out. Let me get rid of this. There we go. Got a plus minus button here, so you can zoom out a little bit. So I'm going to go ahead and do move J. Actually, we're going to move L, and I'm going to say below. All right. Now, automatically on the screen, it shows move L asterisk V1000 Z50 vacuum 1. All right. Vacuum 1 is telling us what tool to use. that will be kind of fun in a minute to show you. Move L is telling us we're going to move in a linear fashion to this point, so move straight. V1000 is our speed, so I really want to kind of bring that down, so we can go ahead and double click on that, and we can go, let's move at a V, I don't know, 200 instead. That sounds good. And our Z is our zone, or how close we have to get to this point before we qualify it as being met. All right. This is more important when you're doing path controls and things like that, but Z50 is fine for our purposes. Now, asterisk. You'd prefer to have a name here, but right off the bat, when you just do a move instruction, it puts an asterisk in because we click on that, and we click on it. Click on this asterisk here. It's not going to let us. All right. Well, let's go ahead and just do a new, and I'm going to call this pen 1. So you can see how you can type with a normal keyboard, and we're just going to leave, and we click initial value here. So pen 1, it's calling it pen 10. Has all this information. Everything in green is inside of was inside of that asterisk. And you can see why it's important that they use the asterisk instead of typing it out, because that's a lot of information. So let me go ahead and hit OK. I'm going to go back to pen 1, hit OK again. And now notice it says move L pen 1. All right, so very, very handy. We can go ahead and hit OK. Now, what I also want to do is, let me go to the jogging screen. I can see my position. We are in high speed mode, which is good. I'm going to go, say, 50 millimeters above this, so 169. Oh, wrong way. Oh, yeah, okay. You know, whatever. That's fine. All right, let me go back to my module at the bottom. Click on add your code here. We're going to do add instruction. We're going to do a move J to this one. This one we can go below as well. And I'm going to create a new one called pen 1 above. Spaces are acceptable at this case. Now the initial value, it defaults to wherever the robot is when you're creating targets like this. So since we're in that position, we can just hit OK. Oh, maybe it doesn't like spaces. That doesn't like spaces. Keep that in mind. All right. And again, I want to make this a velocity of 200 and go ahead and say OK. All right, so now if I actually would go here, and if I hit the hold to run button, actually let's just hit play, what happens? There you go. And you can see we're just looping around. Now, you will see that it's not moving perfectly straight. All right, it moves down in a beautifully straight line, but when it moves back up, you can see it kind of hooks to the left or whatever, just a little bit. That's again because we have a move J going to pen 1 above. All right, so if I go ahead and add instruction move L below this, and I want to make that to pen 1 above again, and now I hit play. Now it'll move in a perfectly straight line each time because we're running all 3 commands, but basically it's going move J pen 1, okay, move, I'm there, move pen 1, okay, I'm down to it, move pen 1 above. I go vertically straight perfect line back up again, and then I'm telling it to move back as a J to pen 1 above again. So it's going from where it is to where it is. That's why we don't see any funky motion going on. So that's how you can kind of write a quick little code using just the teach pendant, and it keeps you doing everything correctly. Now, as a fun little side note here, let's just go ahead and change vacuum 1 to vacuum 2 and hit OK. That is fine. Basically, the program pointer is where we're at in the code. So if I hit the play button right now, it's going to go, we don't know where to start from. So we have to do debug, pp to main, or position to cursor or something. You have to tell it where to put the program pointer. Now, by changing that to vacuum 2, it's actually going to put vacuum 2 in that exact spot via everything else being the same. So it's actually going to rotate this. So if we go ahead and hit play, now you can see without changing anything except for the vacuum position, it now knew I need to use that other criteria. So we didn't have to rotate, we didn't have to change anything. So it was very easy to change which tool it is that we are using for these things. So it makes the coding very powerful and very easy to loop things and go, oh, use this one or that one, or pass different arguments in so it knows which gripper or whatever to be using for that specific task. So overall, that is how you can do a very quick and dirty coding. Oh, one last thing. Notice on the left here, now that we've hit play again, you have a robot position and an arrow. All right. The robot position is basically telling you this is the command we're working on. and the arrow is pointing, saying this is kind of the next command we're going to do when we can do it. Now, that is not so much problematic with the move commands, but if we were setting inputs or outputs or things like that, it actually does that earlier. So like if you were carrying something and you said move to this this location, the next one you said was release it. Well, it would release it as it's in motion going there, because it's going, well, I can do that next component, that next command still. So it would release it. And that is when these different waits come in. All right. So right now we have wait DI, which is digital input, wait digital output, wait time, wait until, while. There are other wait options. There's a whole bunch of other commands in here. If you keep hitting next, it's going to jump you through all of the different basic options. So here we're under various, and I don't know if even all of the options are in here. Look at all the different move options. Holy moly, right? All right. So yeah, so there are a lot of options that you have. I would stick with the standard old, just common ones for right now, and that will make your lives a little bit easier. All right, hope you enjoyed how to get started with Robot Studio.